We're going to cover section 1.2 in 2 days. Today we're going to talk about the real number sets, the properties of real numbers, the 2 questions on your diagnostic that you probably didn't know the answer to. And you had a fraction, you started trying to simplify it, and it asked, what number set does it belong to? Like, pay attention to the question. The question is asking you to tell me the number set that it belongs to, not simplify it. So, I get some of you were just trying to do something, you're a wheel of fortuning it, talking it out loud until maybe you came up with something and hoped for the right thing. Yeah, no, it didn't work. So, let's talk about what it is, okay? So, we are talking about the real number system. Real numbers consist of 2 different subcategories. There are rational numbers and there are irrational numbers. If the number is rational or irrational, it is also real. Now, in parentheses, you will see an abbreviation for that set. You don't necessarily need to know those, but I want to make you aware. The one thing that I do want to be sure that you are aware of is when you write one thing, I'm just going to point this out, and it's just one of my pet peeves. Please do not write ARN for all real numbers. I hate that. The real number set is a script R that looks like that. That R should actually be there, but when I was typing the notes out, I didn't have that option. Okay? So how do you do that? You do the one line first. Okay? Then the curly Q on the outside and kind of come over. And then keep going with the R. That's how you make a script R. That means the set of all real numbers. Okay? You'll get good at it. And even if it's not exactly the same way as mine, it's okay. I know you're trying to make a fancy capital R, and that means the set of all real numbers. Okay? Again, I know Mr. Shuda let you write ARN for all real numbers. Please don't do that. That is not actually a mathematical thing. Okay? The script R means the set of all real numbers. Now, let's talk more about rational numbers and irrational numbers. On your diagnostic yesterday, I gave you an example of a rational number, and I gave you an example of an irrational number. Okay? Rational numbers are any number that can be expressed as a fraction, where the numerator, the top of the fraction, is an integer. An integer is a positive or negative number without fractions or decimals. And the denominator is any integer but 0. So if you can take a decimal or a number and rewrite it as a fraction with integers as the numerator or the denominator, it is rational. Next, an irrational number is a number that never ends and never repeats. Does anybody know a number that never ends and never repeats? Yes, Eric? Pi. The number pi never ends, it never repeats as a decimal, right? It keeps going and going and going. But it doesn't repeat either, right? You know decimals that go on forever and ever, but they have a pattern, a repeating pattern. Those are rational because I can write them as fractions. Okay? Basically, any square root that is not a perfect square is irrational as well. And we're going to get into some of those examples. Chris, you have a question?
Yeah. You said irrational numbers can't be put in as fractions.
Irrational numbers cannot be put in as fractions, correct.
But isn't there a fraction form of pi?
Fractions where the numerator and denominators are integers. That's the key. And we're going to talk about integers here in a second, but that's the key. The top and bottom must be integers. So yes, could I write pi over 1 and make it a fraction? Sure. But pi is not an integer. We're going to talk about what integers are in a second. Okay. I know it seems weird to use the definition of something that we haven't defined yet in our example. Okay, but that's what we're going to do, because there's no other way to do it. All right. And actually we're going to do that next, I believe. Yes. The next set of numbers in the real number system, subset, integers. And it is represented with a Z, a capital Z, because we already used I for irrational. I'm sure Z means something in Greek, maybe. No, it probably doesn't. They just like, man, we used I. What else are we supposed to use? We don't use Z for anything. Let's throw that in there. So that's probably where it came from. A positive or negative number that is not a fraction or a decimal. Okay? So it's the way I like to think about it is and again, this is not correctly using the definition of the word that I'm about to use, but it's a positive or negative whole number. No fractions, no decimals, positives and negatives are good. Okay? No fractions, no decimals. Chris.
But isn't the fraction of pi 22 over 7? So that's what.
No, it is not. 22 over 7 is an approximation for pi. It is not actually pi.
Oh, okay.
It's just like 3.14 is an approximation for pi. It is not exactly pi. But it's an acceptable form to use when trying to get an estimate for a particular type of problem, but it does not equal pi. Okay? All right, next is whole numbers. Whole numbers are 0 on up. No fractions, no decimals. So no negatives. Okay? So it's positive numbers and 0. 0 is not positive nor negative. It has no sign value. So really what whole numbers are, all the positive integers and 0. Again, no fractions, no decimals. The next set is natural numbers or counting numbers. So now we just throw the 0 out. All positives. Natural numbers are counting numbers. When you start counting things, you don't go 0, 1, 2. How many cookies do I have? 1. You don't start with 0. You start with 1. That's what natural numbers are. Natural numbers are part of whole numbers. So this is one of the reasons I've listed them the way I have. Natural numbers are inside of whole numbers. Whole numbers are inside of integers. Integers are inside of rational numbers. Rational numbers are inside of real numbers. So if you have a whole number, it is also an integer and a rational number and a real number. They're like Russian nesting dolls. You know what those are? Okay. The big doll, you take one apart, there's a smaller doll the same size inside it, and then you take another one. That's what it's like. Now, on the next screen, I'm going to want you to take a picture because it gives you a Venn diagram of all of this. And I think it's helpful to see. So, feel free to take a picture of this. Notice here how natural numbers are inside of whole numbers. Whole numbers are inside of integers. Integers are inside of rational numbers. And they are all inside of real numbers. Irrational is just kind of off here by itself on the side. It's real, they're real numbers, but they don't have any other subsets inside of it. On the next slide, I have a bunch of examples. I'm not going to go through them just because of time. And again, if you want to take a picture of the next slide, you are welcome to do that. Okay? And again, I apologize for going fast. We just don't have a lot of time today. So here are examples of all of those things. Okay? Take a picture of that. I will talk through it a little bit and kind of wander through it with you a little bit. But this is something that you're going to want to go back and study a little bit because there's a lot going on here. And over to the right, I have some examples. Okay. So again, if you notice here, an example of a rational number, it can be written as a fraction. Okay, integers on top and bottom. The bottom can't be 0. So any of these numbers that can be transformed into a fraction are rational. Integers, positive and negative whole numbers, so to speak. Whole numbers, no negatives. 0 on up. Natural numbers, eliminate the 0. Irrational, we already talked about pi. E is a number. We will talk about it later on this school year. Any types of square roots that are not perfect squares are irrational as well. If you try to convert them to a decimal, they go on and on forever and ever and do not repeat. The number 5 belongs to all of these sets. It's a natural number, it's a whole number, it's an integer, it's rational, and it's real. So when you get to a problem like this, you're going to have to name all the sets that it belongs to. So yesterday on that diagnostic, that fraction 25 over 11 is a rational number and was a real number. The square root of 50, it's not a perfect square. Square root of 50 was irrational, and it is also real. Okay, so like here where it says negative 11, whole numbers and natural numbers can't have negatives. It can be an integer, it can be rational, and it can be real. That's why you've got the 3 different ones. Okay. We have 2 other properties that we need to hit on, just to make sure we're on the same page, and then I will shut up. Additive inverse is the opposite of a number. And we're talking about opposite, I'm talking about opposite sign. Okay? So if a number is positive, its additive inverse will be negative. If the number is negative, its additive inverse will be positive. Ultimately, if you aren't sure if it's an additive inverse, add the number and its additive inverse together, it will equal 0. If when you add them together they don't equal 0, then one of those numbers is not the additive inverse. All you're doing is changing the sign. Should be pretty straightforward. The reason we need the additive inverse property is for solving equations, right? Remember we do the opposite to both sides? The whole point is making one side 0. That's why we use the additive inverse. And the last property is what's called the multiplicative. It is not multiplicative. The multiplicative inverse is the reciprocal of a number. And remember, we can take a whole number or an integer and write it as a fraction. We just put a 1 under it. So the reciprocal of it, the multiplicative inverse, is just the reciprocal of that number. Okay? How you can tell if a number is a multiplicative inverse, when you multiply the 2 numbers together, you get positive 1. Same idea why we use multiplicative inverse to solve equations. Oftentimes we have a number next to a variable and we divide by that number. The same thing is when we multiply by its multiplicative inverse, it will turn it into 1 and get that number away from the front of the variable. Okay? I apologize that I went through that fast. This video that I just recorded will be uploaded. It will be attached to your assignment, and you can slow it down and watch it again if you need to. Okay? You have an assignment that you're going to work on that involves all this stuff. It's not hard. It looks like a lot of problems, but you're literally telling me what numbers do these what number sets do these numbers belong to? That kind of thing. Okay, so it's not too bad. But if you need to, probably during Flex, I will upload the video. It will be right there next to the assignment, and you can watch it right in Canvas. Okay? Are there any questions? I'll just tell you, normally I won't go that fast. So if you're stressing out about it, don't.